All right, so now we're back. And so working memory has like these two components. There's the span, like how much you could hold in it, and then how the capacity actually gets at like how much information you can handle and process. So this is an example of a task that would be administered to determine a person's working memory capacity. You're told for each of those rows, you'd be presented them one at a time. And for each of those rows, you would judge whether each calculation is true or false. So is 7 times 7 plus 1 equal to 50? So you'd say yes or no. And then you're also supposed to remember the word dog. And that dog was the first word that you saw. Like you're supposed to, the order of the list matters. So you're supposed to judge the accuracy of the calculation, and you're also supposed to try and encode the words that are associated with each calculation and remember those words in order. And typically, what'll occur is they'll show you like one of these. And if you can remember that word, then they'll now on the next trial they'll show you two different rows. And then if you can do that, then they'll show you three on the next one. They'll keep going until you finally can't do it, right? Till you get to the point where, okay, I'm starting to mix up my recall of the words. I'm not remembering them in the order that they're supposed to be. And that will determine your capacity, right? So let's say that you could do a list of, I don't even know if this is possible, but let's say you could do 10. That's a lot. Because this is a pretty complicated thing to be judging these. You see the word that you're supposed to remember, and then immediately see another calculation that you're supposed to process. And so you're kind of, not to put it back in the modal terminology, but I'm going to, you're kind of not rehearsing that word dog as now you're making the judgment about whether 10 divided by 2 plus 5 equals 10, right? So you've stopped rehearsing the word dog because now you've started paying attention to the next task. And so it's a really hard task. Most people can't do very many accurately. Remembering and what I mean by accuracy is remembering those words in the order they were presented. So this performance is what we would call your working memory capacity. Um, so what they have found is that working memory capacity correlates strongly. So that means there is a number that's close. Okay, so I don't know where to start on the statistical description here, because probably you maybe have had some exposure to statistics, but so a correlation can range from 0 to 1, right? And it could be positive or negative, but that doesn't. In this case, we're only talking about positive correlations. So you have a number between 0 and 1. The closer it is to 1, the stronger the correlation is. And the more confidently you can say that one thing predicts the other. So if we have a strong correlation between working memory capacity and, let's say, verbal scores on the SAT, that means that having a bigger working memory capacity score is associated with having a higher verbal SAT score. It also correlates well with other kinds of reasoning tests. There's all sorts of cognitive reasoning tests on the market, and typically people with larger working memory capacity tend to score higher on reasoning tests. And then reading comprehension tests, right? Reading probably occupies working memory. And so if you have a bigger working memory capacity, you probably can understand what you're reading better. So these are all examples of how working memory is correlating with real world measures of these different kinds of skill sets. So it's kind of an argument in favor of working memory as a model. Let's argue against it. First off, the whole thing is unclear. It has some limits on its capacity. It has some limits on its duration, but very unclear, vague and imprecise at all levels. What do you mean by central executive, right? What do you mean by episodic buffer? What are you talking about? Attention is really what we're talking about, honestly. It's not really that much of a model of memory. It's really describing how attention is applied. And the idea that you can apply attention to a phonological task and a spatial task simultaneously, that makes a lot of sense, right? It's an attention model. How it has gotten construed as a memory is kind of odd. honestly. And then semantic doesn't really account for encoding things based on meaning more than you would on something else. Like it doesn't account for the fact that people tend to remember meaningful things better than unmeaningful things or meaningless things. So it kind of is ignoring a really important aspect of how memory systems work, which is that reliance on meaningfulness. So these are some pretty strong arguments against considering working memory to be a special kind of like it would explain memory better than the modal model would or something like that. Kind of argument against that. All right, time for another bias alert. I didn't take the time to make an icon to tell you this is a bias alert, so I'm just going to tell you. The levels of processing model is the model that I used throughout the past, oh my gosh, I don't even want to say how many years of research that I've been conducting. I really have invested a lot of time and energy into testing this model and so far have found support for the model, at least in certain ways. So, bias alert. All right, here's a picture. If I were to ask you to draw this picture, exactly. So maybe I flash it on the screen and I tell you, okay, draw that picture from memory. I can tell you that if you process this picture deeply, that is, maybe you impose some kind of meaning on it, you tend to remember more details of the picture. So let me give you some examples of things that people in research on this picture have said that they did to the picture in their minds to make it more meaningful and that therefore why they produce such accurate drawings. They said I told myself that that circle is a wormhole and that a bird has dived into the wormhole and this is their feet sticking up and their little knees are bent, and so I drew it like it was bird legs with feet on the end and the wormhole circle around it. That's pretty vivid. Other people have said those look like palm trees to me, and that's their shadow is being cast off to the side. So, and then the circle is like the moon or the sun, or they've said different things, but they're like, so that helped them to draw it more accurately because they knew that a palm tree had these things that stick up and that the straight part was straight and then the shadow would go off at that angle and that it all had a circle around it. So the more deeply you can process something, the more likely you are to remember the details of that thing, right? Now, for a lot of us, if we were told try and replicate that drawing, we wouldn't have necessarily thought those details, or maybe we would think maybe less deep and maybe leave some details out. So this levels of processing model argues that there are different degrees of processing that can be imposed on information. Structural processing would be things like, does the word contain an E? Or how many letters does this word contain? Acoustic processing would be like, does it rhyme with the word street? And so for each word that you're assessing, you would judge yes or no whether it rhymes with a particular word. Does it contain an L sound? Would be another acoustic processing kind of task. And then there's semantic processing, where does it fit in the sentence, I met a blank in the street, or your father's brother is your, and you have to fill in that blank. Does it fit into the concept of justice? These are all examples of semantic processing tasks. The model says that the more deeply you process the material, the more likely you are to remember it. So semantic processing should produce better memory than acoustic processing, and acoustic processing should produce better memory than structural processing. So that's the basic model. Let's go ahead and stop here, and I will go that way in the next video I can go through the whole rest of it. And so we'll stop here and we'll pick up with levels of processing.